Now, we are going to construct triangles. We shall begin with the construction of an equilateral triangle. So, one, we shall begin with equilateral triangle. We are going to draw a straight line and then measure this distance, like that, then like that. So to be able to draw an equilateral triangle, this measurement that we took here, we strike an arc on top there. This point again here, we strike another arc there, and then we join the arcs. So we join the arcs. This arc is joined there, and this other arc is joined there. And then we can label our triangle as A, B, C. Then we can measure it. This one is 4.5 centimeters. So this is 4.5 centimeters. This other one is 4.5 centimeters. 4.5 centimeters. So to draw an equilateral triangle, given a side, what we do, procedure number one, we draw our length as 4 centimeters, 4.5 centimeters, and then we get hold of our pair of compass, this distance, we strike an arc on top there, then we transfer this distance here again, we strike another arc, and then we join them like that. Let us have a look at how we can construct an isosceles triangle. So triangle number 2 is isosceles. Isosceles triangle. How do we construct it? Suppose we are given our length as 5.5 centimeters and 4.0 centimeters. So we are going to draw our base as 4. This is 4.5 centimeters. This is 4.5 centimeters. And the other length is 5.5. So we measure 5.5 here. 5.5 accurately. We measure it here as 5.5. And then we put our pair of compass there. We strike an arc there. We also strike from this other point B, we strike another arc. So we can call this as A, B, and C. And then we join the parts. Join the parts carefully. Like that. And then this other one, we join it like that. So this is 5.5 centimeters. This is 5.5 centimeters. And we would have drawn our isosceles triangle, and then we use these two symbols to show that that is an isosceles triangle. This side and this other side are equal. In our equilateral triangle, this side, and these other sides are equal. Now, a scalene triangle is a triangle whose measurements are different. For example, one is 8, 6, and 4 centimeters. 8, 6, and 4 centimeters. This is a scalene triangle. So we can begin with measuring 8 centimeters. So we take a generous length like that. So this is 8.5 centimeters. If you measure it from that point, this is 8 centimeter is somewhere here. So our line AB for the first one is 8 centimeters. Now for the 6 centimeters, this is our ruler. We're going to measure 6 centimeters. So here is 6 centimeters. Then we can stand in either point, this point or that point. We can stand at this point here. We strike an arc there and leave it. And then the other measurement is 4.0. This 4.0. So we measure 4.0 from there. This is 4.0. And then at point B, because we had already utilized point A, we move to point B, we stand there, we make another arc there, and then we join the arcs. This one is going to be joined to that one, this point, and then this other one, we can join it from this point here, that point, and then we can call our point C. This is 8 centimeters, this is 4 centimeters, this is 6 centimeters, and this is called an escalene. This is called a escalene triangle. So when we look at the 3 triangles, this one, the distance is different from this one, different from that one. That is escalene. This side are the same. We call it an isosceles triangle. While this other sides are the same, we call it an equilateral triangle. Now a right-angled triangle. In a right-angled triangle, we can take our length as AB, and even take this length and this length as our AB. We call this point A, this other point is B. Now we are going to construct a perpendicular line at this point. How do we construct the perpendicular line? We put our pair of canvas there, we adjust it to some reasonable level. This we make a strike there, then we adjust it a little bit, make an arc there and another arc down there. We move it to this other point, make an arc there and another arc there. Where they meet, we join the points. Where they meet, we join the points like that. So here, this is our 90 degrees. If you are given 6 centimeters, for example, this is 6 centimeters, the length 6 centimeters, the length from A to B, and this other one was 5 centimeters. What you do, you measure accurately from your ruler 5 centimeters, put it there, measure 5 centimeters like that accurately, and then you transfer it to this point like that. You make an arc there, and then you lengthen this distance so that it meets at our point there, and then we are calling this, how much was it? From there to there is 5 centimeters, and then now you can join the 2 points so that you have a right angle. You can join them so that you have a right angle at these points. So, in summary, we were looking at the construction of various angles. We began with number 1, an equilateral triangle. An equilateral triangle, look at the spellings. Equilateral triangle, equilateral triangle, actually rectified it. And then we have an isosceles triangle. Then we went to a scalene triangle, this one, and finally we have constructed a right angled triangle. Now, when constructing these figures, number 1, you must be neat. I've tried my level best to be neat so that I did not rub. So when we rub, we make our work look dirty. And then you should be accurate when drawing any line. Get the measurement from the ruler. Remember, you begin from 0, 10, 20, like that. You don't forget and begin counting from 10 because you'll be 10 millimeters less. So you begin at exactly 0 because when we are measuring distance, lengths and such like, we normally begin from 0, 10, 20, like that. So be tidy when you are drawing so that in future you can become a real good engineer. Next, we are going to construct quadrilaterals. Once again, quadrilaterals are four-sided figure. We shall have to look at them. We'll have to look at the square,